Hey everybody, so in this video I'm going to review with you for the energy, wavelength, and frequency quiz. Do 3 questions for you that will highlight the different kinds of questions that are on the quiz. So energy is symbolized by the variable E, wavelength is by the variable lambda, and frequency is the variable nu, or this kind of looks like a V here. So the 3 things you have to do for every question are identify what you need to solve for, identify the given values in the question, and determine which equation to use from the ones you have available. So the equations you're going to have available are E equals h nu, and h is Planck's constant, and h's value is 6.626 times 10 to the negative 34 joule seconds. You'll be given that on the quiz. You don't have to memorize it. And as you know, this V symbol, nu, is frequency, and E is energy. You'll also be given the equation C, which is the speed of light. That value is 3.0 times 10 to the 8th meters per second. Again, you don't need to memorize this. It's going to be given to you. And C is equal to lambda nu, the wavelength times the frequency. So you can rearrange this equation. If you want to solve for nu, you can divide both sides by lambda, and you get nu equals C divided by lambda. You can also solve for lambda by dividing both sides by nu, and you get C over nu is equal to lambda. And you notice you can actually plug this into that equation where the lambda is, and you get the other equation that was on your sheet, which is E equals hc lambda. So I'm only going to give you 2 of these equations. I'm going to give you that one, I'm going to give you that one, because these 2 both lead you to getting that equation if you plug it in. So the other thing that you should know is that hertz, which is the units of frequency, is also known as 1 over seconds, or seconds to the negative 1 power. It's a negative 1. Okay, but let's do some problems just to make sure that you know how to do these. So this problem, violet, has a wavelength of 4.1 times 10 to the negative 12 meters. What is the frequency? So we're solving for frequency, which is the symbol nu, and wavelength, which is lambda. So we're going to use the equation C equals lambda nu from the previous page, and you're going to solve for frequency. So you're going to divide both sides by lambda, and you're going to get the equation nu equals C over lambda. So now we're going to plug it in. C is 3.0 times 10 to the 8th meters per second. You'll be given that on the quiz. And lambda, which is 4.10 times 10 to the negative 12 meters. You notice the meters cancels the meters here, because one's on the top and one's on the bottom. And now we're going to plug it into our calculator. So we have 3 times 10 to the 8th divided by 4.1 times 10 to the negative 12. And you get this number, which you need to turn into scientific notation. So the answer is there's 3 sig figs in the given. So it's 7.32 times 10 to the negative 19. And you can either write hertz or you can write 1 over seconds. So I'm going to write hertz. I'm going to circle my answer. And that's how you get full credit on a question like this on the quiz. Taking a look at the next question, it says a photon of light has a wavelength, right? So we're given the wavelength, and it says calculate the energy. So that's E. So we need to use the equation E equals hc lambda. Plug in our constants. Running out of space here. I'll squeeze it in that way. So I plugged in h and c. I'm going to divide by lambda now. This is in centimeters, and I've given you this hint right here to how to convert from centimeters to meters. And that's what I'm going to give you on the quiz tomorrow. So first we convert 0.050 into scientific notation, 10 to the negative 2 centimeters. And it says multiply by 10 to the negative 2 if you want to convert from centimeters to meters. So we're just going to add those exponents. 5.0 times 10 to the negative 4. Remember, when you multiply two numbers with the same base, the exponents get added. So there you go. You see the meters cancels the meters, the second cancels the seconds. One's on the top, one's on the bottom. And now we're going to plug it into our calculator. So it's 6.626 times 10, move it over a little bit, negative 34 times 3 times 10 to the 8th meters per second divided by 5 times 10 to the negative 4. And we get that answer. And so the answer is, with two sig figs, 4.0, right? Because the 7 rounds the 9. 4.0 times 10 to the negative 22 joules. So that's the only unit left over. And that's the joules, the energy of one photon. Which leads us to our next question. How do you calculate the total energy when you're given the number of photons? Remember, when you calculate E, you're calculating the energy of one photon. But when you multiply this, you'll be able to get the energy of all photons. It's like saying, if I know the cost of one piece of candy, well, how many does 1,000 pieces of candy cost? Well, you just multiply it. So we use the equation E equals hc lambda. Again, the reason is you have lambda here and you have energy here. So that's the only equation you can use. So it's 6.626 times 10 to the negative 34, so 4 joules seconds, multiply times 3.0 times 10 to the 8th meters per second. You divide by 3.0 times 10 to the negative 12 meters, which is the given in the problem. The meters cancel the meters, second cancels the seconds because one's on the top and one's on the bottom. And now we type it into our calculator. Clear. 6.626 times 10 to the negative 34 times 3 times 10 to the 8th divided by 3 times 10 to the 12 negative. So the answer is 6. So there's two sig figs, so it's 6.6 times 10 to the negative 14 joules. Remember, that's a joules per photon. What you want to do is calculate the energy of all the photons, 1.5 times 10 to the 13 photons. So what you do is you write the number again, 6.6 times 10 to the negative 14 joules for every photon. Remember, E solves for one photon. And then you're going to multiply by 1.5 times 10 to the 13 photons. Notice the photons cancel the photons, just like in that candy example I talked about. So you type it in. So you say 6.6 times 10 to the 14 negative times 1.5 times 10 to the 13th photons, and you get that 0.99. So, which is two sig figs, which is appropriate. 0.99 joules of total energy. You'll notice that some of the answers are slightly different from the ones on the handout that were given, because sometimes the person who wrote those answers didn't use sig figs properly. In other cases, they used 6.63 times 10 to the negative 34 rather than 6.626. So you get a slightly different answer. Use the variables that are and the constants that are given on the quiz, and you'll be fine. Again, just show your work and write units. So hopefully that was helpful, and I'll be able to answer any questions in class tomorrow. Thanks. Good night.